According to the 2020 National Electrical Code, all exterior wall outlets must be GFCI protected. This includes outlets located on balconies, decks, patios, and other outdoor areas. The NEC is the minimum standard for electrical wiring and installation in the United States, and it is adopted by most states and municipalities. The purpose of GFCI protection is to prevent electrical shock. GFCIs work by detecting small imbalances in the current flowing through a circuit. If an imbalance is detected, the GFCI will trip and cut off power to the circuit. This can help prevent serious injury or death from electrical shock. There is one exception to the rule that all exterior wall outlets must be GFCI protected. If an outlet is located in a wet or damp location, such as a bathroom or kitchen, it must be protected by a GFCI or an SI arc full circuit interrupter. SIs are similar to GFCIs, but they also protect against electrical fires caused by arcing faults. If you are unsure whether or not your exterior wall outlets are GFCI protected, you can ask your electrician to inspect them. Your electrician can also install GFCIs if they are not already in place. The National Electrical Code, or NEC, is a comprehensive set of standards that govern the safe installation of electrical wiring and equipment. It's published by the National Fire Protection Association, or NFPA, and is updated every 3 years. It's important to remember that the NEC is not law unless it's adopted by a state or local jurisdiction. However, it is widely used as the basis for electrical codes throughout the United States. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It's organized into chapters, articles, and sections, making it easy to find the specific requirements for a particular electrical installation. When it comes to exterior outlets, the NEC has specific requirements to ensure safety. Article 210.8 of the NEC addresses ground fault circuit interrupter protection for personnel. This section mandates GFCI protection for 125 volt through 250 volt receptacles installed in specific locations. For dwelling units, this includes bathrooms, garages, outdoors, crawl spaces, unfinished basements, kitchens, and areas within 6 feet of sinks. The requirement for GFCI protection in outdoor locations is particularly important because of the increased risk of electric shock in wet or damp environments. Moisture significantly reduces the body's resistance, making it easier for electric current to flow through a person, potentially causing serious injury or death. A GFCI, or ground fault circuit interrupter, is a fast-acting circuit breaker designed to shut off electric power in the event of a ground fault. A ground fault occurs when current flows through an unintended path to ground, such as through a person. GFCIs work by monitoring the current flowing to and from an electrical device. If there's a difference of more than a few milliamperes between the incoming and outgoing current, the GFCI trips, quickly cutting off power. This happens in a fraction of a second, minimizing the risk of electric shock. There are 2 main types of GFCIs: receptacle type and circuit breaker type. Receptacle type GFCIs are installed in place of standard electrical outlets. They provide GFCI protection at the specific location and can also protect other outlets wired downstream on the same circuit. Circuit breaker type GFCIs are installed in the electrical panel. They protect the entire circuit, including all outlets and devices connected to it. When installing GFCI protection for exterior outlets, it's essential to follow the NEC guidelines and manufacturer's instructions. Here are some key considerations. Firstly, use weatherproof enclosures. Exterior outlets must be installed in weatherproof enclosures to protect them from rain, snow, and other environmental factors. The enclosure should be listed for outdoor use and designed to prevent water from entering the outlet box. Secondly, ensure proper grounding. Proper grounding is crucial for GFCI protection to function correctly. The grounding system provides a path for fault current to flow back to the source, allowing the GFCI to detect the imbalance and trip. Thirdly, test the GFCI regularly. GFCIs should be tested monthly to ensure they are working properly. Most GFCIs have a test button that simulates a ground fault. When pressed, the GFCI should trip and cut off power. If the GFCI doesn't trip, it should be replaced immediately. Fourthly, consider local codes. While the NEC provides a national standard, local codes may have additional requirements. It's important to check with your local building department to ensure compliance with all applicable codes. The exception mentioned earlier regarding wet or damp locations refers to specific areas within a building, not the exterior environment. While exterior outlets are generally exposed to moisture, the NEC requires GFCI protection in all outdoor locations regardless of whether they are considered wet or damp. The requirement for SI protection in certain wet or damp locations, such as bathrooms and kitchens, is in addition to the GFCI requirement. SIs protect against arc faults, which are dangerous electrical conditions that can cause fires. Arc faults occur when electricity jumps between two conductors, creating heat and potentially igniting nearby materials. While GFCIs protect against electric shock, SIs protect against electrical fires. In some cases, a combination GFCI/SI device may be used to provide both types of protection. These devices are becoming increasingly common as they offer comprehensive protection against both electric shock and electrical fires. When dealing with electrical installations, it's always best to consult with a qualified electrician. A licensed electrician has the knowledge and experience to ensure that the installation is done safely and in accordance with all applicable codes. They can also help you choose the right type of GFCI protection for your specific needs. Remember, electrical safety is paramount. By following the NEC guidelines and using GFCI protection, you can significantly reduce the risk of electric shock and ensure the safety of yourself and others. If you are unsure about any aspect of electrical safety, always consult with a qualified electrician. The information provided here is for general guidance only and should not be considered a substitute for professional advice. The NEC is a complex document, and its interpretation can vary depending on the specific circumstances. It's important to stay up to date on the latest code requirements and to consult with a qualified electrician or electrical inspector if you have any questions. In addition to the specific requirements for exterior outlets, the NEC also addresses GFCI protection for other types of electrical equipment such as swimming pools, hot tubs, and spas. These areas pose a particularly high risk of electric shock due to the presence of water and the potential for contact with grounded surfaces. The NEC requires GFCI protection for all electrical equipment installed within a certain distance of these bodies of water. This includes outlets, lighting fixtures, and pumps. The purpose of GFCI protection in these areas is to prevent electric shock injuries that can occur when a person comes into contact with energized electrical equipment while in or near the water. The NEC also addresses the installation of ground rods and other grounding electrodes. Grounding electrodes are used to provide a low impedance path for fault current to flow back to the source, allowing the GFCI to detect the imbalance and trip. The NEC specifies the type and size of grounding electrodes that must be used, as well as the methods for installing them. Proper grounding is essential for electrical safety and is a critical component of GFCI protection. When working with electrical wiring, it's important to always de-energize the circuit before starting any work. This can be done by turning off the circuit breaker or removing the fuse that supplies power to the circuit. Before touching any wires, use a voltage tester to verify that the circuit is de-energized. This will help prevent electric shock. It's also important to wear appropriate personal protective equipment, or PPE, such as safety glasses and rubber gloves. Rubber gloves provide insulation from electric shock, while safety glasses protect your eyes from flying debris. When working with electrical tools, make sure they are properly insulated and in good working condition. Damaged or worn tools can pose a serious safety hazard. It's also important to use the right tool for the job. Using the wrong tool can damage the equipment and increase the risk of injury. If you are not comfortable working with electrical wiring, it's best to hire a qualified electrician. A licensed electrician has the training and experience to do the job safely and correctly. They can also help you ensure that your electrical system is up to code. Electrical safety is everyone's responsibility. By following the NEC guidelines and taking the necessary precautions, you can help prevent electric shock and electrical fires. Remember, if you are unsure about anything, always consult with a qualified electrician. Finally, remember that the NEC is a living document that is constantly evolving to reflect new technologies and safety concerns. It's important to stay informed about the latest code changes and to consult with a qualified electrician or electrical inspector if you have any questions. Staying informed and following the NEC guidelines is the best way to ensure the safety of your electrical system and protect yourself and others from electric shock and electrical fires. The 2020 NEC provides specific guidance on GFCI protection for various appliances and equipment used outdoors. For example, portable generators used at residential sites must have GFCI protection for all 125 volt, 15, 20, and 30 ampere receptacles. This requirement ensures that users are protected from electric shock when using portable generators in wet or damp conditions. Similarly, cord and plug-connected appliances used outdoors, such as lawnmowers, hedge trimmers, and leaf blowers, should be plugged into GFCI-protected outlets. This is especially important when using these appliances near water sources or on wet surfaces. The NEC also addresses the installation of lighting fixtures in outdoor locations. Lighting fixtures installed within a certain distance of swimming pools, hot tubs, and spas must be GFCI protected. This requirement helps prevent electric shock injuries that can occur when a person comes into contact with an energized lighting fixture while in or near the water. In addition to GFCI protection, the NEC also requires that outdoor lighting fixtures be listed for wet locations. This means that the fixtures have been tested and approved for use in environments where they are exposed to rain, snow, and other environmental factors. When installing outdoor lighting, it's important to use weatherproof wiring and connectors. This will help prevent water from entering the electrical system and causing damage or corrosion. It's also important to properly support the wiring and fixtures to prevent them from becoming damaged by wind or other weather conditions. The NEC also addresses the use of extension cords in outdoor locations. Extension cords should only be used temporarily and should be unplugged when not in use. Extension cords should be rated for outdoor use and should be protected from moisture. Never use an extension cord that is damaged or worn. When using an extension cord outdoors, avoid running it through doorways or windows, as this can damage the cord and create a tripping hazard. The NEC also includes requirements for the installation of underground wiring. Underground wiring must be buried at a certain depth to protect it from damage. The NEC specifies the minimum burial depth for different types of wiring and different soil conditions. Underground wiring must also be protected from physical damage by being installed in conduit or other protected enclosures. When installing underground wiring, it's important to contact your local utility company to locate any existing underground utilities. This will help prevent you from accidentally damaging or cutting into a utility line. It is very important to follow the requirements set out in the NEC regarding GFCI protection for safety purposes.